Okay, now we're gonna look at something a little bit different. Let's look at a relationship, because that's what 6th grade math is all about, right? Here we're gonna talk about the relationship between lines, or dimensions, area, and volume. There's a relationship there, and I want us to discover it together, okay? First thing I'm gonna do is I'm gonna just look at this rectangular prism right here. It's got some dimension measurements on it right now. The height is 2, the base is 4, and the depth is 3, all right? First thing I wanna make sure we understand is that this little thing that I've shaded in right here, see this face that I've shaded in? That's the face that I'm gonna be looking at when I'm talking about perimeter and area. Okay, I'm not gonna worry about these ones back here or this one on the side or anything like that. When I'm looking at perimeter and area, I'm just talking about this front face. But when I'm talking about volume, of course, I'm talking about the whole thing, the whole prism, all right? So let's go ahead and fill in the values for these 3 things: the perimeter of that front face, the area of that front face, and then the volume of the whole prism. This shouldn't be too hard. Okay, so follow along with me. If you haven't already, sketch this in your journal so you can have it there, because we're going to be referring back to this prism for the rest of this lesson. Perimeter, that's just the distance around a shape, right? So if I'm talking about the distance around this front face here, then I basically am only caring about the height and the base. 2, 4, 2, 4. So if I add all those up, I have 2 plus 4 is 6. Plus 2 plus 4 is 6, but 6 plus 6 is 12, right? Okay, so here's 12. I'm not really worried too much about units yet. We'll get to that. Area. What's the area of just that front face? Again, the only dimensions I really care about are height and base. So 2 times 4, that's the actual formula for area, right? 2 times 4, height times base, is 8. And finally the volume, where I'm going to need all 3. I need the base times the height times the depth. So 2 times 4 is 8. 8 times 3 is 24. Cool. Done. Now, now comes the interesting part. Let's say I want to make this bigger. Okay? Let's say I want to keep all of the dimensions in the same ratios, but I want to make it a bigger shape. I want to make it a bigger box, okay? So in other words, I'm going to want to enlarge every one of these dimensions by the same scale factor. Now, scale factor, there's that magic word factor in there. Remember, I was using that with ratios and proportions. When we're talking about factor, that means what's the number that we're going to multiply all the dimensions by, so that the shape gets bigger, but it doesn't change any of the ratios between its dimensions, okay? All the dimensions will still be 2 to 4, or 2 to 3, or 4 to 3, okay? I'm not changing any of that. When I give it a scale factor, let's say 2, that means I'm making each one of these multiplied by 2. In other words, I'm doubling the length of all of these dimensions, okay? Let's do that. And I'm gonna write underneath what happens in red when you double these. 2 times 2 is 4. 4 times 2 is 8. And 3 times 2 is 6, okay? So all the red numbers are the new dimensions of my enlarged prism. Now, let's fill these 3 in. Perimeter of just that front face, 4 plus 8 plus 4 plus 8. I have 2 4s, that's 16. I'm sorry, that's 8, and I have 2 8s, that's 16. So my new perimeter will be 20. Make sure I did that math right. No, I didn't. Did you catch me? 4 plus 4 is 8. 8 plus 8 is 16. 8 plus 16 is 24. Did you get me? Okay. Now, area. 4 times 8 for just this front face gives me an area of 32. And then the volume, which I need all of them for, 4 times 8 is 32. 32 times 6 is 192. Does that sound good? Okay. So my new bigger prism, the front face will have a perimeter of 24 units. The area of this front face will have will be 32 units squared, right? Because there's squares in there. And then my new volume of my bigger prism will be 192 cubed units. Now, here's what I want us to try to do. Look at this side, the original, and let's look at this side, which had a scale factor of 2. And let's see if we can figure out some kind of a relationship here. What can you say about the two perimeters? What is this perimeter compared to this perimeter? It's times 2. Do you see that? 12 times 2 is 24, which is the scale factor, right? Because I doubled all of the dimensions. So I guess it makes sense that if the dimension, then the perimeter would also be. Okay, all I've doubled in case of perimeter is the distance around. Okay, look at area. Is area doubled in the new prism? Is 8 times 2 32? No, it's not. Interesting. What is the factor that you multiply by 8 to get 32? It's 4, right? So actually this is multiplied by 4. I'll come back to that in a second. How about volume? What's the relationship here? What's the factor that I'm multiplying by 24 to get 192? It's not 2, and it's not 4. 192 divided by 24 is a factor of 8. Weird. Okay, so believe it or not, there's a relationship here. Can you see it yet? It takes us back to our lesson on exponents. Okay, here's 2. What is 4 in exponential form? How can I break that down into an exponent? How about 2 squared? Does that equal 4? Notice now that the scale factor is the same for perimeter. The scale factor is squared for area in my new larger prism. So if this is just 2 and this is 2 squared, what do you think volume would be? How can you write 8 as an exponent with a base of 2 times 2 is 4, 4 times 2 is 8. That's 3 representations of the number 2. Do you see the pattern here now? Perimeter is just lines, it's just distance, okay? Area has 2 dimensions, it's a 2-dimensional shape. It's squared. Volume is a 3-dimensional measurement for a 3-dimensional shape, and it's cubed. Do you see that relationship? That's a very interesting idea. Let's try another one. Let's change the scale factor and let's see if we can predict what these would be without actually measuring them, without actually doing the measurements, okay? I'm gonna erase all of my old data, all of my old red marks, and I'm gonna change my scale factor now to 3, which basically just means that I'm gonna take every one of these dimensions and increase them by a factor of 3, right? So let's go ahead and measure the original. Well, I guess I shouldn't have erased those, but anyway, the original face right here, just the face, the perimeter, 2 plus 4 was 8, and that gives me, I'm sorry, 2 plus 4 is 6, right? 6 plus 6 is 12. The area was 2 times 4, that's 8. And then the volume was, did I have 24? Yeah. Okay. Didn't need to erase that, but there, it's all back again. This is our original prism right here. Now, let's increase this prism by a scale factor of 3. Okay, I'm gonna go ahead and write those new measurements here, but I'm not actually gonna use them to find the, I'll show you what I mean in a minute. 2 times 3 is 6, 4 times 3 is 12, and 3 times 3 is 9. Just so we have that there, because we're actually gonna check our work in a minute. Can I predict what the perimeter is gonna be without actually adding anything? The scale factor is 3, the original was 12. What do you think the new perimeter is gonna be? Well, basically, all I did last time was I multiplied the original by that scale factor, right? That's all I had to do. So what's 12 times 3? 36. My new prism, the bigger one that's 3 times bigger than the other one, is going to have a perimeter 3 times bigger than the original. But what about the area? Here, I'm going to have 8 times the scale factor squared, right? Because I'm talking about area, which is 2 dimensions. That means if I increase one of these dimensions by 3 times 3, I have to increase the entire front face by a factor of 3 squared. So what's 3 squared? Three times 3 is 9, right? So let's write the answer to that. 72. Excuse me. We're going to check that and see if we're right. How about the volume? The volume is 24, and I'm going to multiply that by the scale factor. And remember the pattern? The perimeter was just times 3. The area was times 3 squared. The volume is times 3 cubed, because we're talking about 3 dimensions, right? So let's simplify this. 24 times 3 to the 3rd power is, 3 times 3 is 9, 9 times 3 is 27. And 24 times 27 is 648. That's big. So if I were to make this thing 3 times bigger on all of its dimensions, its volume increases from 24 cubes to 648 cubes. Can you see how rapidly that grows? Now let's check and make sure we're right, just to be sure. Perimeter we kind of figured out, and we can do that again. 6 plus 12 plus 6 plus 12. So I'll do 6 times 6 is 36. 12 plus 12 is 24, so 36 and 24. I'm sorry, I added that wrong. 6 and 6 is 12. Yeah, 6 and 6 is 12. 12 and 12 is 24. So 12 plus 24 is 36. We got it. Good. How about the area? New area is 6 times 12, which is 72. So our prediction there was right also. How about the new volume? All 3 of them. 6 times 12 is 72, times 9 is 648. Our predictions were correct, okay? We didn't even need this necessarily. All we had to know was what was the original measurements of these, and then multiply them by the scale factor, either to the 1 power, to the 1st power, 2nd power for area because it's squared, or the 3rd power for volume because it's cubed. Okay? That's the relationship I want you to see. All right? Not too difficult. Now, there are there's an interesting exercise that I made for you below, and I want you to go ahead and try this again. In my exercises, I'm actually going to go ahead and ask you to make the new measurements, calculate the new dimension, the new area and volume, and there's also some problem solving in there. Go down and do those exercises, give them a shot. I'm actually going to meet you back here and go over those exercises with you. So good luck on those, and I'll see you in a bit.